Okay, guys, here we are. We're at the last lesson of our parallel and perpendicular lines unit, and today we're actually going to look at the slopes of parallel and perpendicular lines. So, first, we're going to remind ourselves of the definitions of being parallel and perpendicular, and then we're going to investigate how to determine if lines are parallel, perpendicular, or neither, and then how to write an equation that is parallel or perpendicular. All right, so we've talked about parallel, and what I've done is I've given you the symbol for parallel. So parallel, you kind of have just two lines like that. Well, you can't see it, but like that. Okay. We defined parallel lines as two coplanar lines that never intersect. Okay. Now, as far as the slopes are concerned, you could look this up in a graph online if you want to. But parallel lines, we say, have the same slope, exactly the same. So if one line has a slope of 2/3, then to be parallel, the other line has to have a slope of 2/3. Okay, it's exactly the same. The same. It's the same as positive or negative, and what I mean by that is they're both positive or they're both negative, and it's the same exact number. Perpendicular lines are two coplanar lines that intersect at a right angle. And we know that a right angle is 90 degrees. And so when those two lines meet each other, they form 90-degree angles. And here's the symbol for perpendicular. It's kind of like an upside down T. Okay? Now, parallel or perpendicular slopes are a little bit different in their relation. They are what we call opposite, meaning one is positive and one is negative, reciprocals. Reciprocal means you take a number, either the whole number or the fraction, and you flip it. So, for example, if you have a slope that is, let's say your slope was 2, then not parallel, the perpendicular slope to this would be -1/2. Okay, 2 we can think of as being 2/1. So when you flip 2/1, you get 1/2. That's the reciprocal part. The opposite part is that this one's positive, this one's negative. Okay, that's what I mean by opposite reciprocals. All right, so we're going to determine if the two lines are parallel, perpendicular, or neither. And the way I've structured it is I've given you 2 points from line 1 and 2 points from L2. So we'll have to calculate the slope, which we looked at on Friday. We'll have to calculate the slope between these two lines. So here's how I like to organize it. So the slope of line 1 equals, and I used m for slope, and I'm going to use that slope formula we looked at. So y2 minus y1 over x2 minus x1. And when you simplify all that, you're going to get 8/4, which we know reduces to 2. All right, let's look at this slope of line 2. So we come to line 2, y2 subtract y1 over x2 subtract x1. and we do our reducing, we get negative 10 on top, negative 5 on the bottom, which reduces to another 2. Okay? Once you have the slopes, then you just compare. Are they the same or are they opposite reciprocal? These are exactly the same, and so we say that line 1 is parallel to line 2. I use the symbol to actually say it, but you're on your homework. I think you just pick the word parallel. You don't have to do that writing part. All right, same question but different points. So the slope of line 1 equals y2 subtract y1 over x2 subtract x1. And we reduce all that, you're going to get negative 18 on top, positive 6 on the bottom. That will give us a negative 3. So the slope of line 2, y2 minus y1 over x2 minus x1. And we do our reducing, we get 2 over 6, and that is a third. So once you get the slopes, then we do the comparison. This was negative 3, this was 1/3. If I switch the sign, that's going to be, that'd make it positive, so we've checked off the opposite part of it. And then if you flip 1/3, turn it upside down, you'll get 3, be 3 over 1. So that takes care of the reciprocal part. So we say that line 1 was perpendicular to line 2. So those two are perpendicular. You also could have a neither option. So for example, on this problem, let's say this ended up being a negative 2. If this were negative, it would only fulfill this portion of the perpendicular criteria. If this were negative, there'd be no reciprocal, so it can't be perpendicular, and it'd be no longer parallel because parallel slopes are exactly the same. So if this were negative 2, this would be a neither case. You could see that. Okay. Now on the bottom, what I've given you 2 different equations. Different forms of them. But we're still determining if parallel, perpendicular, or neither. So on these kind of problems, make sure everybody is in slope-intercept form. So you want everybody in slope-intercept. Let me make a note of that. You want all your equations in slope-intercept form. So the first one's good to go. That's y equals mx plus b form. The second one is a little bit different. It's not, so we need to change it. So we're going to convert this equation. I'm going to recopy it because we know we need to change it. Slope-intercept form we know is this. So essentially, I need to get the y by itself. So I'm going to subtract the x. What I'm going to do here, because I can't physically subtract those, I'm going to slide negative x in front. And since the 3 was positive, I'll make it plus 3. Now I have to get rid of this 3 attached to my y. And then everybody over here is divided by 3. So that's going to give me negative 1/3 x plus 3 divided by 3, 1. So now we just pulled the slopes out. So we're going to look at this line. What's the slope? It's 3, so I'm going to write it over here. this slope, negative 1/3. So notice they're opposite signs, so that takes care of the opposite part. And they are reciprocals. So these two lines are perpendicular. All right, same thing over here. This is in slope intercept, so it's good. This one's not, so I'm going to convert it. Recopy it for myself. Move the x term. And then we'll divide by negative 2. Remember your signs, negative divide negative is going to make it positive. And then positive divide negative, we're going to get a negative 1 down there. Why can I not write a 1? There we go. All right, pull your slopes out. So from here, I had a slope of 3/2. That's my slope here. Hey, they match. So this is parallel. Okay? So the big idea here is parallel slopes, exactly the same. Perpendicular slopes are opposite reciprocals. You have to keep that in mind. Because what we're going to do now depends on if you're given if it's parallel or perpendicular. So now what I'm going to do is I'm going to give you a situation. I will give you somewhere out in the world exists this line and we're trying to find it. It's going to pass through this point, and it's also going to be parallel or perpendicular to another line. You have to write the matching equation. Okay? So, and to do this, we're going to use this form of a line. That's called point slope. We looked at it Friday. We're going to use that. So we already know the point. We just have to figure out what the slope is going to be for the new line. And what tells us that is this word. It's parallel to this line. So what I do is I circle my slope of my given line. If I want to be parallel to this line, then I need to use the exact same slope. So I'm going to say use -9 as our slope. Now I'm going to use this point in my slope I just found in here. So y subtract y1 is 5 equals my slope times x minus. Now when I plug x1 in, he's already negative. So when I plug him in up here, it's going to change it to positive, and then the 1. Then we'll distribute. Bring that down, -9x minus 9. Now we'll add the 5. Whoops. That is positive. No, it's not. I'm sorry. That is not a positive 4. That's supposed to be negative. Sorry about that. Okay, same thing. We're going through this point, and we want to be parallel to this line. So you might want to make a note for yourself. Parallel means same, the same slope. So whatever slope we have, we will use that slope. All right, y minus y1 equals my slope. X, now again, this is negative, so this is going to change it to a positive. On this side, y subtract 0 really isn't going to do anything, so I'm just going to go ahead and drop it. If it's anything but 0, you need to keep it there. Sorry, sure that's on my other paper. I made a mistake. Need to fix it. So there's the line. Okay? Now you virtual kids, your paper on these two problems probably says parallel. I meant to change it to perpendicular. So if you're taking notes, just mark that out and put perpendicular. I meant to do that before I posted it, and I apologize. All right, same idea now, but instead of being parallel, we are perpendicular. So that means we take the slope we're given. Wait a minute, there's nothing there. What's the slope? We should know that there's an invisible 1 right there. So that slope we can write as negative 1 over 1. And then we're going to come down here and we're going to change it. So first thing is we're going to change the sign. So we're going to make it positive. And then you're supposed to take the fraction and you flip it. So we would get 1 over 1. And we'll use that slope of 1, essentially. And then we'll fill this formula in. Y subtract the y coordinate equals the slope times x plus 2. Remember, it's plus now because this was negative and we put it in. That's not going to change anything. And then we'll add 2. So x plus 4. All right, same way. We're perpendicular. So we're going to use this slope and we're going to change it. That's negative 2 over 1 was given to us. And I put it over 1 because it was a whole number. Now we have to change it. So first you switch the sign. So make it was negative, so make it positive. And then 2 over 1, you're going to turn over. So it'll become 1/2. And this will be the slope we use now. Then we'll fill in our point slope. Y plus 3, it's plus because this was already negative, equals my new slope of 1/2 and x minus x1. Bring this down and then distribute that. Now I'm going to subtract this 3. And so I'll finally end at 1/2 x minus 5. So there we go. That's parallel and perpendicular. So just remember, keep in your mind, parallel is the same slope. Perpendicular is opposite reciprocals. You're going to have to memorize that because that determines how you set up the problem, especially on these kind of problems. Your homework is digital. It is I think it's a little bit shorter assignment, but make sure you watch this video all the way through and then do your homework. And as always, if you have questions, let me know.